Next students, let's discuss how are electrons distributed in different orbits or shells. Now the distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. They provide certain rules which are to be followed for writing the number of electrons in various energy levels or shells of an atom. Rule number 1, the maximum number of electrons present in a given shell is given by the formula 2n square. That means the maximum electrons can be equal to 2n square, where n is the number of energy level or shell. We know that for K shell n is equal to 1, for L n is equal to 2, and for M L is equal to 3, so onwards. Therefore, for K shell, on substituting the value of n in this formula, the maximum number of electrons comes out to be equal to 2 into 1 square, that is equal to 2. For L shell, because n is equal to 2, it is equal to 8. For M, substituting the value of n is equal to 3, 18. And for capital N, it comes out to be equal to 32, and so onwards. Once again I am repeating, the maximum number of electrons that can be present, it depends upon a formula that is 2n square, where n is the number of electrons. Now students, note that in this case, for M shell the electrons are 18, and for N shell the electrons are 32. Now rule number 2, the maximum number of electrons that can be accommodated in the outermost shell is 8. This is most important. Now students, we know that in M shell 18 electrons can be present, and for capital N shell maximum 8 electrons can be present. This depends upon the space that is available. But for the sake of stability, maximum electrons that can be accommodated or can be filled in the shell, it cannot exceed 8. That means it will be equal to 8 only. No doubt M can have 18 electrons, but while writing the formula we will only write 8 electrons in that shell, and similarly for capital N shell we will be writing only 8 electrons instead of 32. That means maximum number of electrons that can be accommodated in the outermost orb is only 8. This is due to the stability reasons. Number 3, electrons are not accommodated in a given shell unless the inner shells are completely filled, that is, the shells are filled in the stepwise manner. Now students, we know that the first shell is K shell, and then after K it is L, and then after L it is M, and so onward. The electrons will be first filled in the K shell, then they will be filled in L shell, and then they will be filled in M shell. That means filling will take place in the stepwise order. Moreover, you should also know that filling takes place in the increasing order of the energies of the shells. This means the energy of K shell is less than L, which in turn is less than M, which in turn is less than N. So we have to follow these 3 rules in order to draw the structure of an atom of a particular element. Now let's take some examples. First of all, let's take an example of hydrogen atom. Now students, in hydrogen only 1 electron is present. Therefore, let's draw the structure of hydrogen atom. We will begin with nucleus, that will be in the center, and the very first orbit that follows the nucleus will be K shell, that is n is equal to 1. And we know that in K shell maximum electrons that can be accommodated is equal to 2. Therefore, since it is only 1 electron, it will goes to the K shell only. So this is the structure of hydrogen atom. Next we have helium. In helium there are 2 electrons. Therefore, both these electrons they will occupy K shell, since K can occupy maximum 2 electrons. So this is the structure of helium atom. Next is lithium, which contains 3 electrons. Since it contains 3 electrons, and we know that in K only 2 electrons can be accommodated. That means after filling the 2 electrons, K shell will be completed. Therefore, the third electron, it will move towards the next orbit and it will be written in the next orbit. So this is the structure of lithium atom. Let's take some another example. Sodium. It contains 11 electrons. Now how these 11 electrons can be distributed in the various shells? Begin with the nucleus. Then the first shell, that is the K shell. We know that maximum 2 electrons can be accommodated. Then next shell, that is L shell. And since after 2 still 9 electrons remain, that has to be distributed. So out of these 9, we know that for L shell maximum 8 electron has to be written, because this we have already studied that in the outermost shell maximum 8 electrons can be accommodated. That means the remaining 8 electrons, they will be filled in L shell, and still 1 electron remains, that will be filled in the next shell, that is the M shell. So you can count the number of electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. That means in this case the filling has been of this order. In K there are 2 electrons, in L there are 8, in M there are 1 electrons. Similarly for lithium, here in this case in K there are 2 electrons and in L there are only 1 electron. For helium, in K there are 2 electrons only, and for hydrogen in K shell there is only 1 electron. So this is the structure of an atom, and this is the mathematical representation of the electrons present in a particular shell. This mathematical representation is called electronic configuration. Electronic configuration. That means the electronic configuration of sodium is 2, 8, 1. Okay, we will be writing it in the form of the filling of the orbits. In K shell it will be 2 electrons, then for L it will be 8, and the remaining last electron will goes to the M shell. So this is the electronic configuration of sodium. So students, now you will be drawing these structures and will be writing the electronic configurations of first 20 elements in your fair notebooks. You can take help from page number 50, where structures of first 8 elements are given. Now moving forward, the next topic is valency.